Hello and welcome back to my channel. My name is Amir and this is day 12 of Advent of Code 2022. So let's get started with the puzzle then. Okay, this is day 12 hill climbing algorithm, and we would like to reach from one position to another. So this is a pathfinding kind of an algorithm, and there are a bunch of rules that we should follow. So let me make this a little bit bigger. So we're starting at S and we need to get to E, and we can only get one step in each direction, so we can go here or we can go downwards. And when we want to choose one of these two paths, the only thing that we should consider is that the next elevation or our next point should be only one level higher than our current position, or it should be equal. For example, if we are, let's say, in this location, then we cannot go to L because it's too down and we want to go up. N also is way down, we don't want to go there. X or X. So based on which way we get to the X, we can go in this direction or in this direction. Or here, when we are in W, we cannot go to H or J because they are way down and we don't want to go down, we want to go up. We cannot go to V because it's still down, but we can go to X. So this is the way to go along. So we should find the way from our starting point to the end point. So this is a pathfinding algorithm. So that should be pretty much it about the algorithm. So let's go and see what we can do with the code. So I can save it here and then I can get my grid, which is the data that I have, and I should split it by new line like this and then map each row to a new array of items. So the row dot split by empty space, and it should be split. Right, so now let me like my grid to make sure that I am doing it right. So node part 1, yes, I'm getting the correct data. Okay, this is fine. The thing is, I don't know which point is our starting or our ending point, so first I need to find these ones. So let me do that. So for I would call it R, and it should go from 0 to grid.length, right? And then there should be another one to traverse the column, so I would call that C. That would go from 0 to grid at index 0 dot length, and we are adding to C. Cool. So if grid at position R and C is marked as S, then it's the starting point. I need to say starting point row is R and the starting point column is C. And to say on the safe side, I will just say grid at R and C is A, is character A, because we are always moving from A and going towards Z basically, or small e. So I'm just labeling this A and I start from here and I would need to get here. Okay, so the next step is to have the same for the endpoint. So if grid at point RC is E, then I would say ER and EC are this, and the grid at that position is called C. But of course I need to define these values, so let SR and SC and ER and EC. So I'm just defining them and then set them here. So this part is done. Now if I log these values, not here, just here, if I log them after the for, I will get 0, 0 and 2, 5, which is the correct. Okay, cool. So this for loop is done. I have nothing to do with it anymore. The thing that I need to do is I need to have a queue, which is basically an array. And what I'm doing is that I'm pushing my starting point to that queue. So I'm just saying SR and SC, and then I'm saying that right now the distance that I have come is 0. So I'm storing the distance as I go along. At the end I can retrieve this. So this is my queue. Now I need to store the visited cells as I go along so that I don't end up going to them again. So for example, if I am C and I have came from C, I shouldn't go back to this, because this can be an infinite loop. From C I will go to C, and then from this C I will go back to this C, and this is an infinite loop that we want to avoid. So visited is also an empty array, and we just push to the starting point the position of our current cell. So which is, for now, this is the starting point. So I will just add something like this. I will say SR is SC. So SR SC. I'm doing like this. You can store it as an array of values, but I think this is like easier to find out. So far so good. Then while our queue still has something inside this, while queue.length, which is true at first because we have just pushed to the queue, we need to retrieve the item from the queue. So I would grab R and C and D from the queue, is the queue.shift. So the thing is, I am adding to my queue from one direction and taking out from the queue from the other one. So if my queue is like this, I will always add items in this side. So if I get a new one, I will add it here, and if I want to retrieve it, I will get it from the other side, so that I don't add and remove from the same side. Okay, this is done. The next part is that I have to find out the next positions that I can go from that R and C position that I am already in. So that is basically an array of a few items. So I can have only 4 different neighbors that I can go at most. So it will be R and C. This can be R plus 1 and C. This can be R minus 1 and C. This can be R and C plus 1, and this can be R and C minus 1. So these are the points that I can go from my current position. So if I am here, I can go this way, this way, this way, or this way. And if I can here, I can go up, right, down, and left. So I am already including this part, but I will remove it in the next state. So I have done this. Now for all of these, for let I is equal to 0 until I is less than, I can say 4, but let me say is less than next dot length. Okay, and I need to add to the I as I go along. So for these values, I will get my next row and next column. My next row is next at index I, index 0. So this will be next row. And my next column is next at index I, index 1. So I'm getting this and this value, and I will check these two. So if nr is less than 0, so if we are here and if we are in this state and we came to this, we want to check this. This is invalid, so we should ignore it. So if nr is less than 0 or nc is less than 0, so we are here, we cannot go up from Q, we cannot go up. Or nr is bigger and nr is bigger or equal than grid.length. So we don't want to go this way. Or nc is greater and equal than grid at index 0.length. So like this. Right. So we don't want to go here, we don't want to go here, here, or here. So if any of these has happened, just continue and ignore. We don't want to do with that cell. The next one is that if visited, if it's already in the visited, if one of these indexes nr and nc is already been visited, we don't want to go there. So from C we came to C and we have already visited C, so we don't want to go back here, we just want to go on to come to here. So on the visited, if you can find a cell which that cell is equal to this value, but not with SR and SC, but with NR and NSC and NC. So if X is equal to this one, then we have already visited that, and then ignore it. We don't want to go with that. Okay, this is done. Another thing that we need to check is that the elevation is much higher. So if grid at index nr nc and get the char code at that one, subtract it from the current r and c, and if this is bigger than 1, so for example if you want to go from I don't know, from L to X, you cannot do that because X is way too high from L to reach that. So if this has happened, then continue. So these are the cases that we want to ignore. Otherwise, you might have reached the end. So if nr is equal to er, which we defined here, endpoint here. So if nr is er and NC is EC, like this, then we have reached uh, the end. Return d plus 1 because in our next step we can get to that. So this is this, and then you can return from the loop. You're done. And if any of these didn't take place, then there are a bunch of items that we can go on to. So just go there. So visited dot push this value, no, not this value, this value, which is of course nr and nc. Just add it to the visited ones and add that next item to the queue as well. So I am just adding nr and nc and then d plus 1 because we have just moved one step forward, right? And then this should be pretty much it. Let me check. This should be length. Okay, we got 31 is the correct answer here. Yes. So let's go with the big data probably. Copy this and paste it here and save it, and hopefully we will get an answer. 437 after a few seconds. So 437. Awesome, we got our gold star. So let's get to the second part then. So to maximize exercise while hiking, the trail should start as low as possible, elevation 8. The goal is still the square marked E, however, the trail should still be direct, taking the few steps to reach the goal. So you'll need to find the shortest path from any square at elevation A. So instead of just moving from S to E, we can go from this A to E or from this A to E. And we need to find the shortest path from all of these. So we could have like a for loop and then check throughout all of these, but since this data is like huge and there are lots of A's here, so we don't want to, take a lot of time with, calculating all of this. But instead it would be fine if we could go from the other way around, or for example, we go from E and then if we get to any of the A's, then we are fine. So other way around, we set E as our starting point and we go until we get to an A. And either of the A works for us, doesn't matter, we need to just to get to one of them. So like this. Okay, so there should be a few changes. Let's get to the code and see. So I will be copying this from part 1 to part 2. The thing is, I don't need the starting point anymore. I mean, this SR and SC are not important for me. I just need to set this to A to be one of the endpoints that I can get to. So I can remove SR and SC from the code. Okay, the next part is that I am starting from ER and EC instead of SR and SC, and I am going on with ER and EC here as well. So these two are taking place. I'm doing this the same way. I'm doing this the same way. This should also be checked as usual, and the visited is also should be checked, but here this should change. This should change that instead of going one up, we just need to go like one down. So it should be less than -1. So the other way around. Instead of going from this to this, we are going from this to this. So this should be inversed. Then this is fine. And let me check my code again. This is okay, okay, and okay, okay. So let me clear this and 2, we didn't get any answer. The thing is, okay, so instead of checking for this, we need to check for that if our next R and next C equals to character A, then we can return. This says 430. Yes, we got the another star. So I hope you have enjoyed the video. Please like, share, and subscribe to my channel if you find it interesting, and